Okay folks, this is going to be worksheet number 1, limiting reactants. This is only problem 1, so we have 6 worksheets out here, 1 for each problem. So if you need a different problem, watch a different one. But this is problem 1. Okay. There's the problem listed, and there are 4 steps. We have to make sure that when we do this, we go through all 4 steps. So we're going to have to write a balanced equation, figure out how many grams of iron chloride are formed, the limiting reagent, and how much is left over, how much limiting excess reagent is left over. So we're going to go through that process. Right. So the first thing we have to do is write the balanced chemical equation. So we have iron, and we have chlorine gas. Chlorine is a Brinkelhoff element, so it's Cl2, and it creates iron chloride, and it's FeCl3 because iron has a +3 charge. So when we balance this, we have to have 2 of those and 3 of those and 2 of those to get a balanced chemical reaction. So that's our first thing. There's our chemical reaction. And now we write down what we know, which is 114.0 grams and 292.7 grams. And this is our unknown, and we're trying to figure out how many grams of that we're coming up with. Now, to save you some time, I have looked up iron and chlorine. So iron is 55.847 grams per mole, and Cl2, that's chlorine, which is 35.453 times 2, which is going to be 70.906 grams per mole. Alright, so now we have to go through our stoichiometry problem twice, starting with our Fe. So we're going to say we have 114.0 grams of Fe, and we have to get rid of Fe, grams of Fe, and go to moles of Fe. And then we have to get rid of moles of Fe. We have to go to moles of our target substance, which in our case is FeCl3. But we don't want moles of FeCl3. We want grams of FeCl3 because we want to figure out how much we actually made. Alright, so let's put in some conversion factors. We know that 1 mole of Fe weighs 55.847 grams. And we know that when we look at our coefficients, we have 2 moles of Fe to 2 moles of FeCl3. So those are going to cancel. And every mole of FeCl3, we have to figure out how much that weighs. Okay, and FeCl3, if we do the math for that, that thing weighs, let's see, I've done that, 162.206 grams per mole. That's the number that goes here, 162.206. Right, when we work that out, we get a total of 331.1 grams of FeCl3. Now we have to do the same thing for Cl2 because we don't know which one is limiting. We aren't told that. So we start with 292.7 grams of Cl2. And we have to convert from grams of Cl2 to moles of Cl2. But we don't want moles of Cl2. We want moles of our target, which is FeCl3. And then we have to get rid of moles of FeCl3 and go to grams of FeCl3, which we clearly know how to do. So, 1 mole of Cl2 we figured out weighs 70 grams. And our moles of Cl2 to FeCl3, you'll notice that's a 3 to 2 relationship. So we have to put a 3 to 2 relationship. And 1 mole of FeCl3 we already know weighs 162.206 grams. When we do that math, we come up with 446.4 grams of FeCl3. So clearly we can tell which one is limiting. That's the one we get less of, where we produce less FeCl3 over here. So iron is clearly limiting, and the maximum amount of FeCl3 we can produce is 331.1 grams. Alright, so that tells us that if we subtract these two numbers, we have how much is left over. So if we subtract 331.1 from this, right, we come up with a total of 115.3 grams of FeCl3 that we were not able to produce. We had enough chlorine to produce it, but we didn't have enough iron to produce it. So how much excess chlorine did we have? We have to work our way backwards to chlorine. How much excess chlorine did we have? Well, if we start out with 115.3 grams of FeCl3 and we work backwards, right? So we're starting with grams of FeCl3. We have to get rid of grams of FeCl3 and go to moles of FeCl3. And then we get rid of moles of FeCl3 and go to moles of our target, which in our case is Cl2 because that's the thing we had in excess. And then we get rid of moles of Cl2 and go to grams of Cl2. Right, now we can plug in our numbers. 1 mole of FeCl3 is 162.20 grams, 206. And for every 2 moles of FeCl3, we have 3 moles of Cl. We're pulling those numbers from up here as our coefficients. And every mole of Cl2 we know weighs 70.906 grams. When we do that math, we come up with a total of 75.60 grams of Cl2, which was not used. Okay, I think that's it. That's the end of the first problem. If you need help, see us in class. Have a good one.